I will teach you how to calculate the bearing capacity of the shallow foundation. The shallow foundation is the square footing with the width of the foundation is about 5 meters. So I would like you to calculate the Q that apply to the foundation, or you can say Q is the safe load. The factor of safety of this question is factor of safety is equal to 3. Friction angle is about 30 and the unit weight of soil is about 18 kilonewton per cubic meter. Cohesion equal to 0. The groundwater level is we're setting this one at the ground surface to make this one quite simple for you. And the other one is that the depth of footing is about 2 meters from the ground surface, and the thickness of the footing is about 1 meter here. Okay, so first I will, before I go to the Python code, I will generate the concept first. How can you calculate for this one? As I mentioned before, firstly I have to calculate for the Q self. Q self is what? Q self is, maybe I should use this color. The Q self is composed of two portions. The first one is the weight of the foundation is made by concrete, and the other one is the weight of soil here. Okay, so I will use the yellow color. So that means if I would like to calculate for the Q self of this question, Q self is equal to the yellow portion. The yellow portion is the weight of the soil. Soil is the weight of the soil. We have to calculate with the gamma palm multiply with H. H is 1 meter. This one is from the soil itself, and the other one is the foundation. Gamma C is the concrete with 1. This one is 1 meter. Yellow, and I think it should be green one. This one is soil, and this one is concrete. If I put number in this equation, gamma prime equal to 18 plus 9.8 plus concrete is about 24 kilonewton per cubic meter and plus 1. This one is the concept of the Q self. And maybe you might have some question about the weight of the column, because the weight of the column compared to the weight of the soil is quite small, so you can neglect the weight of the column of this footing. So this one is this equation to calculate this one. Okay, multiply to this. So if we would like to start with Terzaghi from equation from this footing, we have the Q ultimate equal to CNC plus QNQ plus 1 over 2 B gamma N gamma. This one is the basic equation, and this question is that the foundation is square footing. So I just, if it's square footing, I have to add some prefix, or have to adjust a little bit about this part. If this one is square footing, what's going on? Go back to the handout. Square footing, you can see it here. The square footing is that we have to add 1.3, and this one for the n gamma we reduce from 0.5 to be 0.4. So 1 to add to be this, the red one 1.3, and change this one to be 0.4 square footing. Okay, so this one is a starting equation for calculate from our footing. And when we obtain the Q ultimate, we change to Q ultimate net equal to Q ultimate divided by the factor of safety minus Q self. Okay, it's ultimate, it's a Q self. And the last part of this question is that Q equal to Q self multiplied with area of footing. This one is the final answer. So let I make the conclusion about this question is that firstly we have to calculate the Q cell. Q cell is composed of two portions. The first one is the cell weight of the foundation itself, is made by the concrete, and the other one is the weight of the soil backfill that put it on the foundation, and the weight of the column we can neglect. Okay, that's all to calculate. So the next part I will show you how can we calculate this one in Python. I will tell you how can we make the calculation or calculation report using the Python. For Intersil, then you study the computer programming for a long time, I think, since you are in the first year. But for Thai program, we just study the Python. So firstly, we try to introduce you how can we set up the Python, how can we use this in a web base. Firstly, if you have this kind of web base, you just type Google Collaboratory. Okay, Google Collaboratory is something like this. Okay, after if you log in with the Google account, it will something like this. You will go into the new notebook. This one is my previous one. I go new notebook. Wait for a while. This one, the Python is ready to use. If somebody try to use it, maybe found that it is quite slow. You have to change this one to be connect to the host runtime. So that means everything for the calculation let the Google run in the Google Cloud. So it's faster, because if we run on our computer, we might have the problem or slower compared to the server of the Google. So when we would like to use the Python for first, because Python doesn't have the mathematics equation, we have to import from math, import everything, import stuff. When we finish to type, we can run by click on this. Okay, or we can press shift enter. Okay, we get the same results. This one is the result. Okay, we use only from math only. So from this one, we would like to calculate the bearing capacity of the foundation. So firstly, we will set up about the parameter for calculation. Maybe fs equal to 3, something like this. Okay, we collect. If we would like to know the value of fs, we just use the print fs and then shift enter. It become 3. So this one is quite easy to use. For the next part, for my calculation, the friction angle of this problem is this one. Remark v, we have to note it first. V equal to 30. This one is remarked, and the c is equal to 0. If something like this, firstly I would like to calculate for NC, NQ, and N gamma for the phi equal to 30. So how can we calculate? Actually, we can use from the curve from the chart in my handout. You can see it here. If the phi equal to 30, it's around here, 30 equal to 30, NC we have to go up, which here is about how much? It's about 38. NC is equal to 38. And how about NQ and N gamma? Is quite the same. It's 30. NQ and N gamma is about here. It's about come up to here. It's about NQ and N gamma is about 22. Okay, it's about 22. NQ equal to 22. NG equal to 22. Okay, this one is I remarked a little bit that I use this one is remark option from chart. If you work in design company and you have to use a chart all the time, I think you spend really a long time to make the calculation. So actually I give you the so-called the subroutine. I will copy from this. Okay, I will you guys for the subroutine. Okay, this one is I just put the subroutine first. Is for calculate the NQ, NC, and N gamma. This one has the equation that you can use to calculate. So if I would like to obtain the value NC, NQ, and N gamma, I said NC, NQ, and NG equal to call bearing phi. Okay, something like this. So I run this one first and come back to what is where. Okay, we are bearing is not defined. So finish. NC, NQ, and N gamma. If you like to know the NC value, okay, it's little similar to this one. NC, NQ value 22, and N gamma value is about here. Okay, it's little bit different from the read from the graphic, but this one made everything become easier, become easy and faster. You use from the chart. So I will copy this one up. After by using my subroutine, it's quite easy. In the Python, if you can see it here, the 10 you have to change from the phi in degree, have to change into the radian, 3 over 180. Okay, and multiply with pi value is something like this. So this one I delete. So right now you know you can calculate the parameter is the NC, NQ, and N gamma for calculate for the bearing capacity. So we have to calculate for about the three portions. The first one is so-called I define QC here. QC is equal to C N NC. This one Q is 0. Okay, I can check. C forgot the modify. Okay. Okay, and we go to next part. I have to calculate for Q equal to Q. We have to use the QQ equal to Q multiplied with NQ. If something like this, they have error because Q is not defined. So we have to calculate the Q first. Q is what? Q is a surcharge acting near the foundation. We could put it here. Q is, where is Q? Q is something like this. Q is something like this. Maybe you feel you should not mix it up with the Q cell. Q cell is inside. The Q is outside. Q is here. How much? Q is the total, is the effective stress, vertical effective stress acting around here. So Q is equal to gamma prime multiplied with H equal to gamma prime multiplied with 2. Okay, we back to our code. Q equal to 2, gamma prime is 18 minus 9.81. This one is Q. Time is okay. I forgot to multiply. I'll go in. This is my green pen to add this part. Right, okay, finish. And the last part is the QG is the N gamma equal to 0.4 multiplied with gamma. What is the gamma of this one? I have to add the gamma equal to H. Okay, how can we calculate for gamma? Gamma is the plane of failure below the foundation. The plane of failure occurs below the foundation. So that means all the plane of failure is submerged or fell under the water. So we use this one as the gamma prime. Gamma prime equal to 18 minus G or 18 minus 9.81. This one is the gamma prime. Okay, so we go back to our coding. Is the gamma prime is the 18 minus 9.81. B is the width of the footing. yes, b is a with a footing and multiply with n gamma. Point 4 gamma prime b and n gamma. So let's check. Okay, everything is first done. So we combine it all together for square footing. So we combine it. We have to q ultimate equal to CNC. So for this one actually becomes 0. So but we use the square footing. So the square footing is something like this. As we square footing, we have to put the CNC, the factor before CNC equal to 1.3. So we have to add 1.3 plus 1.3 multiply QC plus QQ plus QG. So we combine it all together is the QC, QQ and QG. So this was the Q ultimate of our equation. So we have to calculate the Q allow equal to Q ultimate divided by Fs. Okay, and we have to calculate for Q self. As I mentioned before in the equation is the Q cell is the gamma prime 1 18 minus 9.81 is the gamma prime multiplied with the thickness of the soil plus 24 multiplied with 1. Okay, the Q self. So we use the Q A self equal to Q allow minus Q self. So we just do the how much for the Q A self. We just Q A. Oh, I should put the A here. Okay, this one is the Q allow self. So this question would like to know the load of this footing with Q. A is equal to Q self multiplied with area of the footing is the B power 2. Sorry, just change this one to make this one easy to understand. Q allow net. Try with B2. So this one is the load of this one. So we just put our answer, print the Q just load equal just adding the in list QA kilo Newton. Just have some space bar. Okay, so our final answer is that the load acting on our footing, the Q allow the safe load that can acting to the footing about 5 by 5 meter is about 5006 kilonewton. That's all for the calculation. If you do this kind of question in Python, when you have the same question when you graduate and you work, you can use this code again, and it's quite easy to calculate. You can just maybe try to use the bigger one, 6, what's going on. You can see it here. It's quite easy to try out. And so I will upload this code. I will upload this code in the GitHub. You can copy from my GitHub and paste in your Google Colabs, and then you can play it around. I hope you enjoy with using the Python to calculate for the bearing capacity of the foundation.